So I guess the group would be their partition, and this would be the star. So if what we find is this, if star.asCar is a star, then yes, indeed. Actually, and not just that, but also the repetition delimiter, the group delimiter is this, right? So this case is we got a pound followed by a group followed by a punctuation where the group delimiter is parentheses. So I guess this should be and the punctuation that follows is a star. The other thing we might want here is we want to make sure we're in the right mode. So here, I guess, if we only want to do this expansion if we are in replace sequence mode. Oh, you're right. It should say star. Good catch. Although this part is going to be funky because here we're going to have to return a token stream, not a token tree, I think. Yeah, that might be problematic. I'm going to have to figure that out in a second. Actually, that might be an easy change. Otherwise, we're just going to keep it the same thing it was. P. So if it's this, then now funky things to do. Here, we're going to have to repeat the stuff that's inside. Luckily, we already know how to repeat groups, right? It's basically what we did up here when we encounter a group earlier, right? Down. So if we go here, down here, right? We're going to expand it into... we're going to run, where is it here? Expanded, we're going to call expand pass. Let's ignore those bits for a second. Yes, expand as many times as for each for each element for each sequence in the range. The problem here is this has to return a stream, right? This is not, we're going to replace the contents of that with a sequence of things, basically a token stream. Whereas what this function currently returns is a token tree. So we're going to have to make this a token stream. Luckily, that's not too hard to do. I should change the stream title to what's going on. Yeah, this is one of the things I think is the biggest pain with streaming is like, I don't want to have to go through all of the different channels that I multi-stream to and give a title each time, but arguably I should. Usually, like, my announcements of the events happen on Twitter anyway. I sort of want all of these to just be synchronized, but yeah, arguably I should. So the real question here is whether I can easily get a token stream from... Basically, here's what we'll do. We're just going to assume that it's the token tree. And then we're going to do iter once tt collect. Because now we can early return in here with a token stream. That way the other code doesn't have to change. Right, so this expand pass is actually not quite going to be this. What it's really going to be is, oh, I forgot. We also need to do this like mutated business. This also mutates. It's true. This is also going to mutate. So here we've encountered a sequence, so we need to expand it as many times as are necessary, which means we basically need to run the expand pass on this substream with the mode that is replacing the identifier. So how's that going to work? Well, it's going to be pretty straightforward, actually. Self from value, self to value, map I, expand, mode, replace, ident. This collect, which is collect here is going to give us the token stream, the concatenated token stream. I think in theory that should do the trick. Oh, this should be rep.stream. You're right. Thanks. Good catch. Where this is going to be a little bit tricky potentially though is can I set the span of a token stream? I don't know. Probably not. Might not matter. What else do I have to do here? I also have to set rest is peak. Because we've now, once we've done this, then we have parsed up to and including the star. All right, this is probably going to be all sorts of broken. 65. If ident, star ident, 114, delimiter. This should be a proc macro 2 delimiter what? Proc macro 2 delimiter parenthesis. We might not even care that it's a parenthesis, but you know, might as well do it properly. This should return out and mutated. So this and a bool. This is going to then map out the token stream because we don't need the bool here. Expand pass. This also ignores the bool. And 162. This should also ignore the bool. Really? Fine. It's kind of sad, but you're right. What? Oh, that's not what I meant. Ref is what I meant. Am I really gonna have to make all of these be that? Pattern underscore not covered. Sure. An underscore is going to mean do nothing. So we're going to go back to making this a mute p. Actually, it doesn't need to be a mute p even. It's just this. 65. Does this really have to be that? Oh, that's so frustrating. Bind by move. P needs to be a ref because ASCAR takes self. She does ASCAR even take self? I'm not convinced. But yeah, that doesn't consume self at all. Alright, use a moved value mode. Oh, that's fine. Mode is all of the things. It is copy, it's clone, it's debug. It's probably other things too, but you know. Ooh. Okay, so let's first see that we still pass the first ones. Great. Okay, so we still pass those. Now let's take a look at 5. So 5, if we go back to our main, let's see what that expands to. Ooh, that got some errors. Expected square bracket, found parentheses. Huh. Oh, that's the compilation. Okay, so what did we generate for this? We generated nothing. I see. So that's probably us generating this message. We expected square bracket, found parentheses. Did we now? Huh. Alright, so something is wrong. So let's see how far we get here. First pass. Second pass. Let's see whether we even get to the right pass. So it... Oh, that's interesting. So it runs the first pass and the second pass. And that is certainly wrong. So the real question is, why does the first pass not catch this? Found square. I'm assuming it's going to hit that number. Wow. It hit that more times than I thought it would. Something's weird. Should not have found it that many times. Okay, well... I guess before... And then here we have the luxury of being able to use rest. Before... Oh, token tree iterator. That's annoying. Found it before derive. Found it before derive. Found it before derive. Why does it call this so many times? The first pass. So confused. Oh, because it runs the second pass. That's why. I see. So really, let's just to make our lives easier. Oops. Macro 2. Let's make sure it doesn't actually run the second pass. Just so that we can... Right. So it found it on derive, and it didn't find it anywhere else. So the first pass did, in fact, correctly replace the thing, but mutated was false. Well, here's an observation. This should probably not do that anymore. What? So somehow it... Alright, what does it look like after the first pass? Expand here. After first pass, it looks like this. Out. After the first pass is just a pound. That seems wrong. Out.extend. self dot expand to mutated. Oh, I wonder. Which pound did it find? So it found the derived pound. And then after the pass, is that the same span? The bytes are a little off. 3730. No, 3738. Okay, so after the first pass, the only thing that's left is the first pound. So the one that's before the derive. So this makes me think that this code, for some reason, ends up replacing the entire stream with just the first pound symbol it finds, which seems not quite right. So do we even get in here? Time to replace. I seriously doubt it, but you know. We did not. So it gets to here. So that's a punct. Expand. I guess we're gonna have to now have that. Oh, expand TT now have out. In fact, let's do expanded. It's this extend expanded. Expanded to that. Let's see what this actually expands to when we run it. So it expands the pound and it expanded to pound. So that seems correct, but why does it stop iterating? Why on earth does it stop iterating at that point? Because the stream we get in should be the full program stream. Right? Like, if I do this, presumably that's the full program. It is not. It is just the very first token. Wait, where does stream come from? Am I doing something stupid up here? Oh. What is this token tree? That just seems wrong. The token stream that we get when we parse the stuff in the braces. What is content and what is TT? This is something stupid, isn't it? Yeah, this just seems wrong. The content, it's saying that when it parses the rest of the input after the range with braces, the content is just this, actually just this symbol, which is just not right. Huh. Because, like, if we go up here, what is input at this point? Oh, wait. Maybe I'm just reading this wrong. I'm totally just reading this wrong. All the characters are there. I'm being stupid. I just read this as just the punctuation. Never mind. I'm being very stupid. Ignore me. Okay, so we do actually... I'm being very stupid. So found pound before the derive. Right, so the rest of the stream still has things like the star that we want to expand. Okay, so it found pound before. It's not in that... It is in that mode. So in theory, it should go in here. Peeking. It does go into peeking. But it doesn't go into here because it doesn't find the appropriate pattern. So it returns the punctuation, which is correct. And then it returns the correct token tree. That's what it expanded to. Then it extends out with that. So the real question is, why does this not do another iteration after that expanded to? Yeah, I know about debug. It's just in my fingers at this point. The debug macro is really nice. Also, gotta use an and else. You move the thing inside the debug. Oh, yeah, sure. That's fine. So the real question is, why does it stop consuming things from the token stream? Why does it think the token stream is empty? Does the peeking not actually work? Okay, let's first of all make this clone rather than consume the rest of the input. Great, much better. Okay, now what did it generate? Okay, so it's walking the stream, found a bunch of derives. That's fine. It walks some more. It found enum, found interrupt. Then it finds delimiter brace. So it finds this square bracket, which is this brace. Yep. And inside of there is the pound, the parentheses token stream that contains the stuff where we need to replace things. Punctuation. Found pound before. I see what's wrong. I see what's wrong. No, never mind. I don't see what's wrong. Okay, so it found a pound before the correct thing. It decides it's time to replace. Okay, so it correctly identifies that it's a pound followed by a group followed by a star. So now it doesn't expand on the inner bit. So it expands IRQ to IRQ 0 followed by a comma. It replaces IRQ with IRQ 1. So all of those are expanded correctly. So the full expansion of that pound is IRQ 0 followed by a comma, IRQ 1 followed by a comma. Okay, so all of that is correct. So it correctly expands that. expanded to, so overall, that group expanded to a brace. So this is the group that starts at here. So that expanded to a group with delimiter brace. So that's the variant list. Followed with that contains a stream that has IRQ0, IRQ1, IRQ2, etc. So that all seems right. It just seems like it doesn't realize that it's done. Oh. I know why. It's because the mutate happens inside of a group, and this doesn't propagate that change to mutated. Okay, so this is going to have to be this expanded G mutated is this expanded and then mutated or equals G mutated. Yeah, now we're talking. So now it expanded to all of them. Beautiful. Right, so the problem was this wasn't propagating out the mutated to get back from expand pass. And therefore, this call had mutated be false. So it thought the first pass didn't change anything, so it ran the second pass. All right, cargo test. Oh. Okay. Nice. Okay, progress. So number 6. Make working function. As of verse 134, function-like procedural macro calls are not supported inside of a function body by the stable compiler. What do you mean inside of a function body? When you enable this test case, you should see an error like this. Cannot be expanded to statements. Optionally. Okay. Great. Yes, I did see that error. Now what? Optionally, if you have a nightly tool to instead temporarily adding the following features to this test case. But before you move on, let's fix this in a stable way. Check out the proc macro hack crate for a way to make this work with relatively little effort. Shouldn't need to be any change to the macro implementation for this test case beyond picking up proc macro hack. But for the completeness, the expanded code here will look like that. Interesting. Oh, what a surprise. The workaround is also written by David. Crate doesn't contain nothing but procedural macros. Private helper functions and private ones are fine, but nothing can be public. Oh, that's so funky. Shouldn't need that. Hygiene structure says that the expanded code can't refer to local variables other than those passed. Must refer to a local variable. Fake call sites. But why? I mean, it's not very hard to fix, I suppose, but why is this fix even necessary? Lib. Okay, so we don't need these anymore. So what do I need to do? I need to do this, and then make this, no, where is it? Down here, it needs to be a proc macro hack instead of a proc macro. Does that just make things pass? Oh, fine. What? Oh, right. I still need extern crate proc macro because it's special. Proc macro is the crate that the compiler exposes, which apparently still requires. Okay. Ooh. Unresolved imports. What? Well, that did not work. Interesting. So now seek is not being exposed at all. So this really makes it seem like proc macro hack does not work correctly. Huh. Don't you need at least 2 crates? Oh, 2 crates are required. I see. The implementation and the declaration crate. That's awkward. Oh, I see. That really is a hack. Okay, so that means we're going to cargo new lib sec proc. And then we're going to move source lib to sec proc source lib. We're going to move copy cargo toml to sec procs there. And my this, oh, never mind. And then here we need a source libbar. What? Yeah, that's fine. And that's gonna have this. Proc sec. So this is gonna have a sec proc, which is gonna be equal to path sec proc. And this should not have that, right? And this should be like sec proc. And this needs no other dependencies? Or something? Actually, it needs proc macro hack, right? And also macro expansion ignores token curly brackets. That seems even more broken. this should not be necessary. Or this. So I am running on beta currently. So I don't know if there's something on beta that would make this not work. Macro expansion ignores token curly bracket and any following. In the... Wait, in our main. Why? And any following. Why? Am I missing something from this? Like, macro hack. Yeah. And this does the right thing there. This externs, this uses. They both depend. Implementation crate. Using. Why? How is this different? Let's see. Is this a known issue? One closed. Rust macros in expression position must expand to an expression. I see. So this is really saying. So this is, the claim here is that this is a bug in our implementation. That we have to produce something that's valid in expression context. What does this test case say? Shouldn't need to be any change to the macro implementation for this test case beyond picking up a macro hack. Huh. I mean, sec macro input. I'm not sure I understand what it's complaining about, because in this case, expansion ignores. I mean, this seems like exactly the same error. Expression position must expand to an expression. So this suggests that it thinks that what we're generating here isn't valid. Wait, let's see exactly what it is we generate. So here, this gives me a let z equals that. Fine. No, actually, I specifically want this, which I think I can. Is this legal? How does it crash before I even produce any output, though? right? Like this seems to complain about the input, not the output, because I don't even get to the point where my output happens. Right? Here. Ignore some and any following. I think this is a test case bug fixed in master. Okay, let's do a git fetch upstream. Okay. Doesn't seem like it. Does it need to be fixed in earlier test cases too? Yeah, because I think the problem is the earlier ones. Let's see. New text. Keep the original seek macro for use outside of function bodies. Introduce. Oh. I see. Oh, that's funky. Okay. Source lib. So this, you're telling me that what I should do here is have this be a proc macro and this be a proc macro hack. It's going to be this. And then source lib, this guy is going to use, I guess, this and this. And now cargo R. Do I not need to attach that one? Okay. Yeah, great. So this is basically keeping the old one the way it was, but introducing a wrapper for the test case. Okay. No, that's fine. I mean, it's nice to, so we have David in chat, and it's very handy that he could just fix the test case while we were running into it. eSeek. So should it be eSeek or fseek? I guess eSeek. Did I just like read it wrong? Did it say? Yeah, it says fseek. I see. So this text should say fseek. It should say eSeek. Nice. All right. So cargo test. Yes. All right. We have 6 make working function. Progress. All right. 7. What do we got in 7? Should hopefully be a freebie. Ooh. Freebie? 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 Freebie. Yeah, I like freebies. 8. Oh, inclusive range, huh? Okay. Fine, David. I will implement inclusive ranges if you insist. Okay, so this should hopefully not be too bad for us. I think actually we're going to change the orientation here a little bit, and rather than store to and from here, store range, which is going to be a Rust range. Range. Isn't there a... Really? Is there a separate type for inclusive range? didn't think there was. Yeah, there's not. Fine. To, from, and inclusive. Inclusive. Is the range inclusive? So the real question here is, how do I optionally parse a token? I don't actually know. What does parse say? Haha. I'm guessing it's this one. Just gonna let inclusive is token dot. Actually, it's gonna be option token dot parse input is some. Yeah, that's sort of what I guessed. Let's fill up our main again and expand. Inclusive. Ooh, so many errors. Expected literal. Did you expect a literal? Don't think that's true. Oh, sorry. This should go before 2, of course. Expected literal. Are now written as ... equals. And you should swap the order. Inclusive ranges are now written as ... equals. Yeah. That's what I'm parsing. But why did it expect a literal? Oh, it's a specific. I see. So it's really that I have to do this. It's considered one token. Dots one exclusive inclusive. It's not 3 tokens. It's and then I guess I want to assert if not. I think really here's what I want. I can't option that. Why can't I option that? Oh, I guess I could just parse it as fine. I can parse it as a range. Fine. I give up. I give in. Expert range. Fine. I will parse it as a range. Okay, fine. Why not a range? Wait, what do you want me to do here? You want me to use peak. So, okay, fine. I see. So I can't. What does parse give me actually? Parse buffer peak. I don't have a parse buffer. Oh, I see, from parse stream. I see. So what you really want me to do here is with the parse buffer do a peak. I see. So here this is going to be input dot peak input peak token ... equals, and if not inclusive, then just to give a better error message, we should be able to do token parse input. I don't think this will work because I think this is going to generate a type. Oh, token here. Expected literal. Oh, I see what you mean. Yeah. So we need to... I see. You see, this is what you want me to do. Except this would be that, and this would be this. Because we need to consume the input regardless. Right. And I still want this because I want the variable. And I want this and this. Yep. Nice. Ooh. Oh, right. We're not actually using the fact that it's supposed to be inclusive. Great. And then we're going to do self.from. There are two places I iterate, so let's make an actual iterator. It's going to give me pull. You know what? So because we're operating on numbers, we can do this. Normally you can't do this. Normally these are not the same. But in our case we can. Except this has to be value, and value. And then this is going to be self-range, and this is going to be self-range. Some big pyramids. Yeah, these are kind of unfortunate. It would be a lot nicer if you could use AND and if-lets. I mean, arguably we could like split this, for example, into a function. But there's a lot of like local annoying stuff where we're going to have to pass all the arguments along. All right, progress. 9. What do you got for us now? Procedural macro API uses a type called span to attach source location and hygiene information to every token in order for compilers to appear underlined in the right places. Procedural macros are responsible for propagating and manipulating these spans correctly. The invocations below expand to code that mentions a value missing 0, which does not exist. When the compiler reports that it cannot find value missing 0, we'd like the error to point directly to where the user wrote missing #n in their macro input. For this test to pass, ensure that the pasted together identifiers is created using the span of the identifier written by the caller. If you're using the nightly toolchain, there's a nightly only method called span join. Yep, so that we would get it to span including the #n. Yep, I think this is just going to pass. I think we've been good enough for that to happen. Yeah. Why don't you use the inclusive range and the range method? So the reason I don't do that, if you take a look at it, fn range. So impl iterator requires there to be a single concrete type that implements. It's not a din, right? It's an impl. And dot dot equals returns a different type. This is why earlier I looked up standard ops range and see how range and range inclusive are different types. And so therefore I can't return both. Like I couldn't do dot dot equals here because these two if arms would have different types. I could return a box, right? I could do a box din iterator, but I can't do it with impl iterator. All right, 10, interaction with macro rules. Suppose we wanted a seek invocation, which the upper bound is given by the value of a const. Both macros and const are compile time things, so this seems like it should be easy. I suspect it's not going to be easy. In fact, it isn't. Because macro expansion in Rust happens entirely before name resolution. That is, a macro might know that something is called mproc, but has no way to know which of many mproc values in the dependency graph this identifier refers to. Or maybe the mproc constant doesn't exist yet when the macro runs because it is only emitted by a later macro that hasn't run yet. In this compilation model, it isn't possible to support a query API where the macro can give it the name of a constant and receive back the value of the constant. All hope is not lost. It just means that our source of truth for the value of nproc must be a macro rather than a constant. The code in this test case implements this workaround. This test case may or may not require code changes in your seek macro, depending on how you've implemented it so far. Before jumping into any code changes, make sure you understand what the code in this test case is trying to do. Okay, let's do it. So this uses eseek, source of truth. Call a given macro, passing nproc as an argument. We want this number to appear in only one place so that updating this one number will correctly affect anything that depends on the number of procs. I see. Make procs array. Make procs array. Oh. Pass proc. Make procs array. So this calls the macro make procs array with the argument 256. So calling make procs array with 256, this is going to be a literal 256. So this will work just fine. And this is going to call the macro literal identity macro with the value 256. It returns 256. So this is set. So in theory, this should just work, I think. Nice. All right, so this means that we now have all of the things. Right? Pass all the test cases. Good job. We did another macro exercise. All right, let's do git add dot seek implemented and push that. Beautiful. All right. Now, what exercise should we do next? Given the time we're at, I think we should do sorted because my theory is that it will be faster than trying to do custom debug. I don't think we'll have time for Bitfield. So I think, in fact, Bitfield might be a good exercise for you as the viewer to do after having gone through this with me. Okay, so let's do sorted. So in theory, all this does is it's like it's almost like a clippy lint, right? It checks that the variants of the enum are in the right order, and then emits errors correspondingly. Correspondingly? Is that a word? Unclear. All right, sorted, huh? So let's go to sorted. Cargo Tomo. I'm going to assume that we're going to need sin 15. We might not need quote, actually. Come to think of it, do we even use quote? I might be able to just remove quote from the other one. All right. Sorted source lib. And test progress. First test. 0, 1. Parse enums. Main. All right. See what it says. This test checks that an attribute macro sorted exists and is imported correctly into the module system. If you make the macro return an empty token stream or exactly the original token stream, this test will already pass. Be aware that the meaning of return value of an attribute macro is slightly different from that of derived macro. Derived macros are only allowed to add code, so what they return is compiled in addition to the struct enum that is the macro input. On the other hand, the attribute macros are allowed to add code to the caller's crate, but also modify or remove whatever input the attribute is on. The token stream returned by the attribute macro completely replaces the input item. Right, so this is what we talked about earlier when we talked about both derive builder and when we started on Seek, how there's a difference between proc macro derive and just proc macro, where proc macro derive adds code that includes like the implementations and the other types, but it doesn't change the originally annotated type. Similarly, a proc macro, if you annotate a function with proc macro, it replaces that entire token stream with the implementation of the macro instead, right? So that what that means is the meaning of the function signature token stream to token stream is different for the two. For the custom derive, it's here's the token stream for the input. Now produce a token stream to add. For proc macro, it's here's the input token stream. Here's return what to replace it with. And in the case of attribute macros, it's the same. It also replaces the original input item. So it's more like a proc macro than it is like a proc macro derive. Also parse the input token stream as a SYN item. In order for item to be available, you need to enable features full. Since by default it only builds the minimum set of parsers needed for derived macros. Great. So let's do that. Here we're going to use SYN. Actually, what even are we going to use here? My guess is I'm just going to bring in like the other things that we know we probably need. So proc macro 2 is version 04. And we're probably going to need SYN. Actually, we might not even need anything from SYN for now. So recall from the previous stream that for SYN, there's this like super handy dandy proc macro input macro, parse macro input macro, where we do like this parse macro input args as SYN args and item. Specifically, we could probably parse it instead of just parsing it as an item. We actually know that it's an enum, but that might not matter. I don't know if there's an enum item. Probably not, actually. Is there an item enum? Great. Let's just parse it as an item enum instead. So this is going to be our type. And this is going to be any args to sorted. And we assume that we assume that args is going to be empty. All right, so here, let's go into sorted, cargo T. Actually, let's do cargo expand first. Huh? Did I do something stupid? Yeah, I did. And of course, we also need to use SYN parse macro input. SYN arg, SYN meta, builder source lib. What do we parse that as? Oh, interesting. Interesting. Sorted source lib into does not exist, huh? 2 tokens. I guess what you're saying is also bring in quote and use quote 2 tokens. Really? I mean, I guess we could do that, but it seems like a waste. Quote, quote. Expected proc token stream found proc 2. Great. And I want a debug of this, and I want a debug of this. Unexpected end of input, expected ident. Oh, it's not a meta, is it? Let's see what args actually is. But we also, what did we say? We needed features to be extra traits and full. It's an empty token stream. Maybe it's just adder. I forget what is, so derive input is a thec of attribute. I think it's a I feel like this was meta. Like, okay, so we're trying to figure out how to parse the pound sorted in the first place, and I feel like this was called a meta list. Maybe meta list. Yeah, something like that. Although it's not quite right either. Meta. Yeah, meta. So why can't I parse that as a meta? Yeah, meta is a word like test in that. Great. But it's not letting me do that. Why does it not let me do that? I mean, I guess args is empty. Oh, I guess, okay, fine. So for now, we're just gonna assert that args is empty, and then we can get back to that later. But for the time being, cargo expand of that just now produces the enum that we originally had. Great, and we parse it. So we should pass the first test. Beautiful. All right, test 2, so progress. Show me test 2. Sorted macro is only defined to work on enum types. So this is a test to ensure that when it's attached to a struct, it produces some reasonable error. Yeah, so we just parse it as an enum item. I see. So here we sort of cheated actually by parsing it as an item enum, because here the argument is really that we should use compile error. Like if you remember back to when we did the derived builder, we had to basically emit compiler error statements in the output token stream to make sure that we produce the right errors. And here, really what the intention was that if the thing you got was not an enum, you emit a compiler error thing that says this thing is not an enum. Yeah, but we might not need to do that in theory. It expected that we say expected enum or match expression. Oh, I see. So this is what, sneaky. So the exercises haven't told us yet that they want sorted to work on match as well. And so therefore, we can't get away by parsing it as an item enum because it's supposed to also work on match, which means that it's going to have to be an item. And that would have given us the right thing here. Okay, so let's do it the way it's supposed to be. Parse it as an item. And then we're going to basically, I guess, match on tie. Actually, we don't even need to do that. If let syn item met enum. So I guess where's item here? So if it's an enum or it's a match, I assume match is a thing here. Oh, it's not, is it? Fine. Okay, fine. If tie is that, if tie is that, then we return the enum. Otherwise, match is a statement or expression, not an item. We'll get to it in the later exercises. I think for now we'll just do it the way they want. I also want this to not have to do this. I want to operate on procmarcro2. Actually, here. Procmarcro2 token stream. Actually, what am I doing? Let's just do this instead. Sorted impl args input. Then, because now we can just do this and not have to deal with it. Because now this can return quote, actually it's quote spend, I guess. And here I want tie.span to compiler error. Compile error. And it should say expected enum or match expression. Actually, why am I even doing that? Could just do this. Use quote and quote spend. Proc macro crate types. Oh, this is a private function, so that's fine. It does a return, doesn't it? Fine. So we'll do this. This will just take input, which is going to be a syn item. tie and really? Didn't think that would be necessary. Yeah, something's not right there. I guess this is really gonna be... Wait, why is there not a span on syn item? That seems not quite right. Okay, what happens if I just do this? Then it won't highlight the right thing, I think. Like if I now go here and take this thing and go to main and then run this, what's it gonna tell me? Well, I mean, that business is all fine. Macros suspend to items must be limited with braces or followed by semicolon. Macros that expand to items. That seems unfortunate. Oh, actually, that basically generates the right thing. I'd prefer it if it highlighted the next item. There is. No, there's not. I just tried it. See? Use syn span span. This gives me a syn item. Input span. Run that. Oh, strict span is private? Oh, spend. Span. I can't spell, can I? Great. Oh, interesting. This is all sorts of not what I wanted. Also, let's stop doing this debug print. Macros that expand to items must be delimited with braces or followed by a semicolon. Oh, I see. This arguably should still be input, probably. Huh? Fine. No? Really does not do the right thing. Oh, you're right. I'm being stupid. Because we're replacing the whole thing. And so it needs to... Yeah, you're totally right. Great. It's still highlighting something kind of weird. It really ought to highlight the whole item, but it highlights only the visibility, which is kind of weird. I see. So it actually wants us to not highlight that. I mean, I guess that's fine. Like, we can easily just do that. It seems worse, but okay. All right. So progress. So 3. Out of order. At this point, we have an enum. Let's do this. Oh, now we're getting there, right? Now we have an enum that's out of order. When your implementation notices a variant that compares lexicographically less than the one of the earlier variants, you'll want to construct a syn error that gets converted to token stream by the already existing code that handled this conversion during the previous test case. The span of your error, which determines when the compiler places the resulting error message, will be the span of whichever variant name that is not in the right place. Ideally, the error message should also identify which other variant the user needs to move this one to be in front of. Okay, so here what we're going to do is, if it's one of these, right, so I think the suggestion here is basically have another function that returns a result, and then down here we're going to turn that result into a compiler error if necessary, right? So if we look at O2, syn error provides a method to render your error as a token stream. Great. So up here, the recommendation here is basically have this return a result, I guess, procmarcro2 token stream, or a syn error. And then this can now return a error. What is this? How does syn error work again? Syn error. New. Great. Syn error new. Ooh, I don't know what span to give it though. Span. Yeah, see, it's also kind of annoying. The problem here is parse macro input produces a token stream. So I can't put it in here because it wouldn't have the right return type. And I don't want to use the span of the input because I want to use the span of args, basically. See, it's unclear what span I even want to use here. I don't think I want to give it a span. So I think actually in this case, the span of args is call site. What is call site? Oh, I see. It's the call site of the macro. I see. So how do I get one of those? Ah, I see. So here, really what I want to do is new where I give proc macro 2 span call site. And then the error message I give is that. And then this is going to be okay. This is going to be unwrap or else e dot to compile error, which we can write as syn error to compile error dot into. But we can't because deref and into. Great. So now let's see that it still produces the right thing. Okay, great. So for 3, now we don't actually check that they're out of order. Great. So we're now to the point where we need to check that the variants are in the right order. Now check variant order. So this brings us back to, we have a syn item which contains an enum. So we have an item enum and we want to walk the variants, right? So for variant in e dot variants, probably by ref. Because punctuated implements iter, right? Yeah, great. Dot iter. So it's going to give us a bunch of variants, and each variant has an ident. So name is going to be variant dot ident dot toString. And now what we want to do is check that these are in order. And one thing we could do is just allocate, basically parse all of them into a vector, sort the vector, and see that it is the same as the original vector. The other alternative is let mute last is string new. If name is less than last, then we return. Then we want to return an error, because in this case, name should have been before last, but it was not. So in this case, it would be variant.span. So we're going to have to bring back use in spend. And the error message is going to be variant out of order. And then last is going to be name. See how that works. Variant out of order. Something failed. Is that what we expected? Yeah. Now, it also says, ideally, you would tell us where it really should have been, right? I mean, let's first see whether it gives us. Okay, what does it expect us to give? Something failed, should sort before that failed. Ah, I see. I mean, this is luckily pretty straightforward. Names is going to be a vec. If not names is empty, and names dot last dot map l is if name is smaller than last, unwrap or false. Names push name. So in this case, we now have all the names in order. So we know that names is always going to be in lexicographic order, right? So what we can do is should be is going to be names dot binary search name, right? Slice. Pretty sure there's a binary search in this somewhere. Oops, this one. Yep. Nice theme. Do you have a setup for download? Yeah, I have there's a separate video where I go through how my whole setup works. You can take a look at that if you want. So basically what we do is we're going to search for where this name should have been in the list. Unwrap or else. I guess we can match on that. Okay means that the name was already in the list elsewhere. So I think we can actually do, which the compiler would already complain about. So we can here do unwrap error. So the error type here is what index it would have come right before, right after. Inserted while maintaining. Yeah, so this is where it would have been inserted. Which means that the element at that index is the element it should have been placed before. Right? So, here, oops, here what we want is format. What was the message? This should sort before that, where that is name should sort before names should be. So this would be I guess, what should we call it? Should be is a bad name for this variable. It's like next lex I. Let's see how that expands. Oh. Something failed should sort before that failed. That seems promising. Perfect. All right, progress. 04. This is similar to the previous. We want to ensure the macro correctly generates an error when the input enum is out of order. But this time it is using an enum that also has data associated with each variant. Okay, so in theory that should be a freebie. Ooh, it's not. Huh. This seems wrong. Here, there are a bunch of warnings. Oh. No, this is probably still us. Probably doing something wrong. So if we expand this, what does it expand to? Oh. What? Oh, it doesn't emit the enum. That seems like a problem. I see what's going on here. So we don't emit the enum if we give the error, but we should, right? We should still keep the original enum in there. And because we don't emit the enum, a bunch of other warnings appear. So because we know that sorted is never going to change the enum, I think what we're going to do here is mute out. It's going to be that out dot. So this result is really going to be empty. It doesn't have to produce anything. And then we're going to do... Oh, I see. Yeah. I think out is just going to be equal to input. And then if let error e is that. Yeah. This is what we're going to end up doing. Right? Then out dot extend this. And then out dot into. Into. Cannot infer type for A. This should be token stream. Yes, token stream from. Great. And now this OK doesn't actually have to return anything because we're always going to emit the enum back out. And this input is, we can just clone here, that's fine. Oh. And this is going to clone that input stream. Great, so now we still emit the output, but also the error. Great. All right, progress. 5, match expression. Get ready for a challenging step. Much bigger change than the others so far. Great. Not only do we want sorted to assert the variants of an enum are written in the order of the enum definition, but also inside match expressions that match on that enum. Currently, though, procedural macros on expressions are not allowed by the stable compiler. To work around this limitation until the feature stabilizes, we'll be implementing a new sorted check macro, which a user will need to place in whatever function contains such a match. The sorted check macro will expand by looking inside the function to find any match expressions carrying a sorted attribute, checking the order of the arms in that match expression, and then stripping away the inner sorted attribute to prevent the stable compiler from refusing to compile. Note that unlike what we've seen in the previous test cases, stripping away the inner sorted attribute will require the new macro to mutate the input syntax tree rather than inserting it unchanged in the output token stream as before. New procedural attribute macro called check. Parse the input as a syn item fn. Traverse the function body, looking for match expressions. Easiest if you use the visit mute trait from syn. Yeah, see, I wish the visit mute or visit were documented, because currently they're a bit of a pain. For each match expression, figure out whether it's sorted. Should be able to get the expression. Okay, great. So let's copy this into our main again, so we have a thing to look at. And back to our source lib. All right, so we're going to define up here a proc macro. What did he say? Right. Yeah, so procedural macro attribute check. Be the same thing. We're going to parse that as an item fn. And let's say that sorted impl is a bad name. Let's say sorted variance. And then down here, we're going to say sorted match. Great. So this is still going to include the original thing that was given with the attribute. So now we're going to have to write sorted match. And the input is going to be a syn item fn, right? Because it's an annotation on a function. And like before, we're going to reuse this error type of ours. Great. I guess we do get to use visit after all. Viz. No, that's not what I want. I want back to syn, and we want visit mute. Okay. So here we're gonna have a struct lexicographic matching, and we're gonna implement syn visit mute for that type. And in particular, in fact, I think this called out which one we wanted. Visit expr match. So we're going to want that function, which is going to take, that's not what I wanted. Visit mute. This function. This is going to be a syn expr match. And specifically, remember how down here. Oh, that's right. We can't do the same thing. I lied. If we oh man, we have to remove the sorted attribute regardless, because otherwise the program won't compile in the first place. So I think what we want to do here is be a little bit more careful. And specifically, we're going to do that by not having this business and instead doing this. Like so. Not going to do this thing. Not going to do this thing. And instead just do... so how is visit mute supposed to be used? I guess it's supposed to be used like mute f, right? And then we're going to do f f dot visit item fn mute. No, it's not true. We're going to do lexicographic matching dot visit item fn mute. Yeah, at mute f. And now we still have the f. And at this point, what we want to do is this lexicographic walk is going to insert the compiler error for us as well. So all we really want to do here is just return back out the f. It might not quite work that way, but you know, roughly. Great. So here, what we want to do is it should be m for match. Okay, so what we now have is a syn expr match. Expr match. So the first thing we have to do is check that there's an attribute there that called sorted. So if m attrs iter any a is equal to sorted. If not that, then return. Oh, we also need to add the visit dependency. Really? Is there a visit mute as well feature? Apparently. Okay, so visit mute. And I did something silly, didn't I? So for the attribute, oh, I'm gonna have to parse it as well, aren't I? Ooh, this is gonna be annoying. Because what I really want to do here is like attrs is gonna be. Ah, no, that's fine. Any a dot path sort of equal to sorted inside the current one. Oh, you're right. I can't even do that. I needed to visit all the arms as well. Okay, fine. So check. All right, and down here, what we want to do is we want to walk all of the arms. Although there's a, actually, we can do a little bit better because visit mute has this thing, which I assume these functions are the default implementations, which means, where's visit expr match? Mute. Yeah. So here we can just do syn visit mute this with the visitor, which is self, and m. Keep recursing. So really what I want to do here is, if this is true, then check the variance. But crucially, this is not quite sufficient. What I want is, well, sort of. I guess I want to remove sorted, right? So we need to make sure that we remove this attribute, which we can do with retain. Not equal to sorted. I probably can't use equal to string, but it's easy to fix later. And then we want to walk all of the variants of the expr. Expr match. Okay, so for each, I guess each arm, names is going to be avec new. For arm in arms iter, we're basically going to pull the same trick here as we did above. Ooh. I see. It can also be multiple patterns, which is all sorts of weird with this. Like, what do we even want? Like, if the user writes something like match foo, and I guess they annotated with sorted, and then they do A or Z this, B this, or Z this, I guess. I mean, like, is this a problem? I don't know. What if they do Z or A this? What are we going to require? Right? This is why every arm has multiple patterns. I think we just want to look at the first pattern, at least for the time being. So name here is going to be arm pats. Pats is terrible. Iter next unwrap. We could stringify the full pattern, I suppose. That's a good point. Is that what we want to do? Can I even do that? Like, does this implement display? It's not clear to me that it does. I mean, it implements toToken, I suppose. Yeah, like I could quote it and make it a string. But it's also unclear that we're going to require the full pattern to be alphabetic. I'm not convinced that's the case. I think we're just going to leave it like this for now. Oh, it gets even worse. Like, what if the user writes this, right? And then they write like x at a, whatever, a at z. Is this wrong or not? Interesting. No, only accept items won't work either. Right? You still run into the same issue. Like, you want to handle things like pattern structs, tuple structs. I think we do require anything that's named. So I think the options are like tuple structs, structs, and idents. And for the ident, we only care about the subpattern. I think really what we want here is a get arm name, which takes syn pat and gives us a string. It's going to match on arm. It's going to match on the arm. And if the arm is syn pat struct, then it's going to do something. If it's tuple struct, and if it is an ident. So if it's an ident, a pat ident, then we're just going to match into the subpattern, I think. So then we're going to do get arm name of ooh, I guess option string. Then this is going to be I dot subpat dot map. Actually, as ref map sp. Actually, I don't care about the at, but I do care about this. That gives me a sub pattern, which is going to give me, so this is going to be an end then. The other thing that's going to be annoying here is to get out the, is possibly at least to get out the span. But let's stick with this for now. So this is going to give me the SP. Anything else is none. If it's a struct, then I want it to give me, it's probably just like the path. Yeah. Then it's s.path, which probably has a toString. It does not. Why does it not have a toString? Let's try it and see if it does. I feel like it should, but I'm not sure if it does. And the tuple struct is probably exactly the same, where it has a path. Yeah. Actually, you're right. This could be sin pat ident. I could just like match into this, where what I care about is subpat is sum. And then I don't care about this, but I do care about the subpattern. I do think I care about other things than just idents. Like for something like matching on the struct, like that seems totally reasonable to also order. If it's an ident, the question becomes, do I match on the bound variable name or do I match on the variant? And I think matching on the variant is actually the right thing to do, because the named binding is just going to be a variable name. For example, the named binding could be nothing. Yeah, exactly. The subpattern is, if I write, at least if I understood this correctly, like if I do foo at barzu, right? It's the barzu I want to sort by, not the foo, because the barzu are the variants of the enum. And so that's the thing I want to sort by, not this. And this is the subpattern. The other question, of course, is whether, yeah, so path doesn't implement toString, which is a little awkward. M.arms, that's fine. Yeah, so all of these come down to I have a path. And I want a string representation of that path. Which, like, maybe what that gives me, but simple path. So unhelpful. What does path segment give me? Path. Oh, because it can contain types and stuff too. It might actually be that what I really want here is to... I'm surprised the path isn't display. That seems wrong. right? Because I guess it implements 2 tokens. So, so can I do like this? Or better yet, what does 2 tokens give me? It gives me a token streams. In fact, the other option here is to do this. But that's not going to be very nice. I actually want to print the path itself. Yeah, I'm going to need quote, aren't I? Quote. Okay, so here we're going to do just the sort of silly f this ts into. That's fine. And of course, yes, I do need to include this. Path doesn't implement display. Pattern doesn't mention fields. That's fine. Okay, so all of these now are about how do I get a string for a path. Okay. Path as string. So I know that doesn't work, but let's at least move all the code to use this. So this would be path as string s.path. This would be the same. This would be path as string this, and same here. Definitely less efficient than it could be. And now the real question should just be this. Oh, I guess this is going to have the same property as up here, where this. Where this is going to be get arm name. Get arm name of that. Unwrap for now, although that won't actually be an unwrap down the line. Variant.span. So this is actually going to be arm.span. 59. This. Yeah, we're going to have to figure out how to change that too. I think this is where we're going to inject the error if something is not sorted. And I think we need to inject that into the body of the arm, maybe? It might not matter. It might be we can inject it anywhere. There is a path.isIdent. Ooh. Okay, so that saves us from this one. But it doesn't really help with the others where I want the full representation of that path. So here, I guess what we're going to have to do is something like m dot, where's the thing where I get expert match, arms on a given arm body. So box expression. It's going to be awkward actually to modify this. Oh, I guess actually what I can do here is just like an error is going to be a vec of sin error. So here I can just do errors.push this. So we just accumulate all the errors that we find. And then at the end here, what we'll do is do that, and then ts.extend. I guess we can derive default for this. LM is lexicographic matching default. LM that, extend LM errors into iter map. For each error, we need to do to compiler error. Great. So now I think the only thing is 49. I think the only thing now is the whole path to string business. 62. What? No field errors. Errors. Yeah. I mean, it might be that we can just do this. Format should sort before I/O. That seems promising. Did that really just like work? I find that hard to believe. Oh, hey, finally. It's funny how I think most of the people who watch these videos have not watched it live. The advantage is now you can ask all the questions. It's the real upside to watching it live. Hey, great. That worked. Okay. Now that we have some experience with visit mute, thinking back to when we did seek, I don't think we could have used seek for this because the input is just like not valid. It's not a valid AST. So I think the parsing would just fail, so we couldn't use visit. Or fold for that matter. All right, so progress. 6. Pattern path. Main. So let's see. When we checked enum definitions for sortedness, it was sufficient to compare a single identifier in the name of the variant for each variant. Match expressions are different in that each arm may have a pattern that consists of more than just one identifier. I mean, this is what we looked at earlier, right? Ensure the patterns consist of a path are correctly tested for sortedness. Path, tuple, or struct. I think we just get this for free. See, I knew it wasn't just ident. Oh, so close. This is just the only thing that's wrong here is that we don't know how to print a path. Or rather, we turn a path into a string the wrong way. Fine. Path dot. Let's go back to where's the? Oh, that's far away. That's annoying. So we could, of course, just render the path ourselves. Seems a little broken, but you know we can do it. Just by saying, I really don't feel like we should need to do this. This is why I wanted to take a look at the like solution, so to speak. Repositories, just to see how David writes out a sorted. Great. Source. Visit. Yes, so see here as well, David just takes the path, quotes it, and takes toString, and then you end up with these spaces around the colons. But then, how do we generate the right thing, the right error? Idents of path. Oh. He actually keeps the idents rather than the string representation. It's unclear that that's important for us. Oh, there's also path. What does path do compared to ident? So path. Oh, we might have to handle path as well. Okay, so let's go back here and make sure we also cover path. So that's path p dot path. I don't know what Q self is here. Qualified with a self type. What's a Q self? Oh, it's like an ask as thing. Okay. Wait, so what? Oh, you've posted solutions in here. Neat. Proc macro commit 8e320. Nice. Oh, I see. They're not on the master branch. They're just like disjoint commits. Right. Yep, so that gives you a bunch of paths. That's fine. Yep. Oh, I see. You make the two implementations common by having them both produce paths, and then you just check the paths. That seems reasonable. I see. Yeah. But isn't this... Okay. Where does the error come from? It's the emit that's tricky, because when I just quote, it's basically how do you print a path? I see. Okay, so you just construct it manually. So this means it does not include like the leading colon, for example. Yeah, I mean, I guess we could do that. Makes me sad, but you know. Great. Because I think in theory we can just do this, right? Because each segment is like that, and then join this. What does path segment implement? Implements. Wait, what? Segment format formatter. But path segments are also not display. Right? Path segment. Oh, I guess we can quote the path segment, but I'm not sure why. Okay, fine. So we could do like quote this. And then you need to do this. And then you can join it. Yep. Let's see. Okay, so. Oh, the span should span the whole path. Whereas for us, it does not. Right? So the error messages are the same, but the span should cover the whole path, not just the first part. I see. Well, we already set the span to be the span of the arm. I guess you want it to be the pattern? Oh, this is because you use the path. I see. So the solution, why is the span of the arm just this though? That just seems broken. Okay, so maybe we should refactor ours to talk about paths instead. So rather than have, get arm name, we have get arm path. Gives you a syn path. I guess it can give you a reference to it. And that means this is going to give you arm path. This is going to give you this. This is going to give you that. This is going to give you this. So now up here, get arm path. I guess really what I want this to do is, what do I even want to do if a thing that's marked as sorted, a given entry has no path? Oh, I guess this is where there's like a, if I read this correctly, it's like a not supported by, yeah, unsupported by. Let's just unwrap for now. That's fine. So this is a path. And I think really what I want here is path.span. But we could still leave the name as path as string path. Why is the span still wrong? Because this should give the full path here. Error format should sort before error IO. And this is printed from the path. But the span of the path is only this? Oh, is this where we need to use Oh, you're right. It's the whole like the error new can only take a single span. Okay, so new span, and then I guess give the full path. I think you're right. I think that's what we did. Okay, great. Good catch. Nice. Okay, great. There's still some like weirdity here, right? Like we might want to support other types of paths, or we might want to support them differently. We might also want to try to like share this loop with the loop we use for checking variants. But progress. 7. Unrecognized pattern. Macro won't need to define what it means for other sorts of patterns to be sorted. It should be fine to trigger an error if any of these patterns is not something that can be compared by path. Be sure that the resulting error message is understandable and placed correctly underlined in the unsupported pattern. I see. Yeah, because here it's marked as sorted, but the things don't have a path. And so in those cases, I think we're actually still in pretty good position, right? So down here, I think maybe what we want to do here is if let some path is that, then path. Otherwise, we're going to push an error saying that arm.pat arm.pats. Actually, that might not even work. We'll see. And then it should say something like unsupported pattern, I'm guessing. Unrecognized, unsortable pattern. And it should say... Actually, it doesn't even have to do that. It can just say this. What am I missing? 7. Right. Okay, and we did something wrong because we said this, right? So I don't know if span is implemented for vectors. Apparently it is. Sweet, so it highlights the pattern, it says unsortable pattern. What does the test case require us to say? Probably something similar. It requires us to say unsupported by remain sorted. Why does it have to say that? I mean, we can pretty easily make it say that, but I don't know why it has to say that. That seems odd. Alright, now what? Unsupported by... We're not allowed to omit all the errors. Okay, we actually emit too many errors, so we emit an error for every pattern that we don't support, whereas the given solution expects us to only emit an error for the first one. So I mean, I guess that's easy enough for us to fix. Intuitor, take 1. Sweet. All right, progress. Last one. All right, 08 underscore main. This is A. There's one other common... What did I miss? There's one other common type of pattern that would be nice to support. The wildcard or underscored pattern. The sorted macro should check that if a wildcard pattern is present, then it is the last one. I see. Well, we can do that pretty easily. So... Up here, what we can do is else if arm.pats.iter.next.map. Actually, just that. If that is synpat, what did we say? Wasn't there a wildcard pattern, right? Somewhere up here, wild, pat wild. I guess W. Let mute wild is none. Then wild is sum W. If wild, if let sum W is wild, so this means that we encountered an arm after we already had wild. Well, that's an error. Right? And we can in fact break. There's no reason to process any of the other arms. There's no reason to check them. And in fact, that also sort of means that we can do that here too. Wildcard pattern should come first. And then in fact here we can give the wildcard as the error. Point to the real question, I guess, for the span of this error is whether it should point to the wildcard pattern or whether it should point to the arm that came after the wildcard pattern. Also, that should say last, not first. Continue. If that is equal to that. Unsupported by remain sorted. That doesn't seem right. That's definitely not what that should say. Continue. What? This suggests that we're not extracting the right thing. So I guess P. Show me what that thing is. What is it we're not handling? Oh, ref P. We're not handling Rustfest. Rust. Oh. Ident. Oh, is the... Ah, so this was your point back then, Felix. That the... Oh, that's so weird. So the sub-pattern is... What then? Like from the opening square bracket? Oh, that's interesting. The other question is whether I can get to a path, whether I can make an ident into a path. I mean, probably. see at box pattern. Yeah, that's what I looked at, but that doesn't actually explain it. I see. So I can take, okay, so if this is an ident instead, then, or if I want the ident out instead, then really what this should give me is, I guess really then what I want is an ID into, like a sum ID into, which gives me a path. So this means that this has to be owned, which is probably fine. Ref. Huh. Okay. But does that actually give us the right thing though? I mean, probably not, but it's probably the wrong message. Oh, right. I mean, can't be printing out all of these things. That's not okay. Wait, we just passed the last one? Wildcard pattern should come last. Did we just guess the right? That's too funny. Underscore. Oh, there's no associated check for 08 underscore. Oh, I see. So there's no actual check for test 8, which is why it was fine for us to not give any text. Wait, so this means we pass all the tests. There are no more tests. Nice. There's probably like a decent amount of cleanup here to do some code sharing between the different implementations. We could also do some tidying up of how to handle paths. But overall, this now like does the exercise. Yay! Well done us. All right, so we've done, this means that we've now completed, well, we completed derived builder last time. We've now done seek and sorted, which I think means that if you've followed both of these videos, you're now in a good position to try out Bitfield and see if you can make it work. Of course, you could also like warm up with custom debug. Great, which I think is pretty good on time. I think this is a good place to leave it. As I mentioned early on, no, that's not what I meant to do. As I mentioned early on, this will probably be the last procmacro stream for the time being. And instead, next stream is going to be whatever you all vote up. My plan for now is that it's going to be another open source contribution stream. So feel free to send me ideas of projects you would like to see me contribute to. I'm not going to work on very large projects because it's very hard to make meaningful contributions to them in relatively small amounts of time, like for these streams. So try to find smaller projects where you think it would be interesting for us to dig into them. The contributions we make can be smaller too. They can be things like reading the code and contributing documentation or contributing more test cases. All of these are totally fine. They don't have to be code contributions. I get the request about something about Noria a lot. I think it's unlikely that I do a stream on Noria because it is just like not, from a code perspective, it's not that interesting. And I could spend a bunch of time talking about the research project, and that might be interesting, but it's not really a live programming stream. There's also some pretty good, there's a talk up from 2 Sigma from last year where I talked about the system, and I did a podcast interview with the Co-Recursive podcast a little while ago. This one. So you can listen to that too, where we talk through basically a lot of how Noria works, what the inspiration was for it, how the implementation works. And so this covers a lot of that in detail if you're curious. If you have ideas for things you would like me to cover, then please send them, just ping me with them on Twitter, send me an email, or leave a comment on this video and I'll check them out. Of course, it could be that by the time we get around to it, people upvote some other idea over open source contributions, but I think currently it is like very high in the rankings. And I think with that, we're done for today. Thank you all for coming out and joining me live. And if you're watching the recording after, thank you for watching. And I will see you in probably 3 weeks. Yeah, probably. Great. Thanks for watching and come back every and any time.